Hey guys, so in this video let's look at all those queries practically. So now let me open our server. Okay, so I think you do remember that we have created all these 4 tables in the last video. Okay, now let me open my query tool at this table. Okay, so let me select start from. So we have 4 tables with us, right? Okay, so let me select all from players and run. Okay, so this is our table. So we have 3 players. Okay, so now let's start off with a simple filtering queries. Okay, so from this table I want to retrieve all the all the player name who who are having the role as batsman. Okay, so this is my requirement. Then okay, how can I do that? Okay, so I can simply say from where the role is equal to a batsman. Okay, if I'm gonna run this query, then okay, if I run this query I get okay these two. Okay, these two as my output. Okay, I did mention star here, so we're getting all of them. I can simply say player name. Okay, now I will get only the names of the players who are having the role as a batsman, right? So this is a level 1 query. Now let's go to the level 2 query. Okay, for the second level query, okay, I'm going to use a nested query. Okay, let me see. I'm going to use the players, right? Okay, let me select. Fine. Okay, we have the team ID and okay, let's see another. Okay, this isn't working. So we might need 2 tables. Okay, let me select another table as well. Okay, let's select star from player stats. So is there a table that we have? Okay, do we have this table? I'm not sure. Yes. So yes, we do have this table. Okay, so and this is players. Okay, now let me paste a query and let's analyze what we have here. Okay, so I'm selecting the player name from players where the player ID is in. So okay, what is this query selecting? So it is selecting the player ID from the player stats where the run scored by the player is is greater than the average run scored, okay, from player stats. Okay, this might seem bit okay. I think it's a bit heavy. So okay, let me see all those players who have scored runs. Mhm. So let me once again view the stats. Okay, I want to retrieve the players who have scored more than 60 runs. Okay, if 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 that is the thing, I'm going to say who has scored runs greater than 50. So we can have these 2 records. Okay, so if I run this query, so what are we expecting? Okay, here it is going to return 2 IDs, 102 and 103. Okay, and so this will be my result set. So this result set will be given to this. Okay, so this is where this is where we have called it. So the result set that we're gonna get here is 102 and 103. So this will be a result set. Okay, so what will this fetch? So we are selecting player name from player. So in players, in the players table, the 102 ID is of Rohit Sharma and the 103 ID is of Virat Kohli. So we are supposed to get these 2 player names. Okay, so let's run this and see if we are getting the desired output. Yes, we are getting the output. So this is how. So in this unnested query, you can observe that this entire query has no relationship with what's happening here, because okay, it is internally using a different table. But even if you are using that even if you're using that same table, but if you're not referring to the outer table using some kind of an alias, So that means that this inner query was supposed to run independently. So wherever the query executor sees such kind of queries, it is going to run that inner query first and return the result to the outer query. Right. So this is about the level 2 query. So for joins, okay, let's do an inner join. Select this, okay, from the players P, okay. We do have another table called teams. Okay. Select star from teams. Okay, if I execute this and see what we have in teams. Okay, in teams we have CSK, RCB, and KKR, and the cities. Okay, now let me paste this new query. Okay, what is this query doing? So we are doing an inner join on players and teams. So how can we join the players and teams? So what is there? Okay, in players, okay, I can see that we have the team ID, the team name, and city. So what is the common column between the players and teams? If we run it, we can see that we have the team ID in the players table as well as in this table as well. So if we were to join these two tables, we have to use that that same column which is present in all of them, right? So what is the expected output of it? So we are selecting the player name and the team name. So who are the players? So we have three players. So we have three players from the team IDs 1, 2, and 3. So what are the teams with IDs 1, 2, and 3? So we have 1, 2, and 3 SCSK, MI, So the expected output would be MS Dhoni CSK, Rohit Sharma MI, and Virat Kohli RCB. Right? It should be the output. Okay, let's run this and see. So yes, we're getting same output, right? So we have joined these two. So these two tables were joined on the common column that both of them have. We can even have a referential integrity. We can even write a foreign key to ensure that only the teams which are present can be assigned to the players. Okay, we can enforce rules. That's why okay, we did discuss about them in our previous lectures. Okay, so this is the inner join. So we can see that we only got the common values, so we didn't get anything extra. But what happens if I say uh, okay, right join? What happens if you say right join? Okay, let me execute this. So we got another entry, and it was given a value null. Okay, uh, why would we get a null value? It's because, see, as we have mentioned, we are doing a right join. It is going to give the hash priority to this right sided table, which is the teams. So it will fetch all of the records of teams, and it will see if any of them match. So for CSK we had a matching. So for MI we have a matching. For RCB we have a matched record, but for KK we didn't find any ID that was matching. So we didn't get anything. So we have given it a default value null, right? So okay, what happens if we say left join? Okay, left join is almost the same as right join. It's just the same functionality will be visible on another table, which is on the left. Okay, if we were to run it, we get same output as inner join, because in the left one we don't have anything which doesn't uh, as, satisfy the condition. So all of the records do satisfy the condition, so we don't have anything which has a null value. But okay, let me insert one more record to let this work. Okay, let's say I'm inserting. Okay, insert into players. Okay, players values. Okay, let me insert a new value. So it shouldn't have any corresponding team ID, so I'm going to write a team ID of 4 probably. Okay, I'm going to write a team ID 4. Let me check the players. Okay, I have to give the player ID. I have to give a name. Right, and then I have to mention the team, so I'm going to say a team ID 4. Okay, we don't have any matching record for this in the other table. Okay, it says that players violates foreign key conditions. Okay, so we have to mention 5 because okay, it makes sense because a 5 is present. Okay, so we are not supposed to do that, right? Okay, so I think it's not a great example for me to explain left join. Okay, let's see what happens if I say full join. A full join is nothing but the outer join, the a full outer join that we have seen in the last lecture. So it works the same. It will fetch all the records, right? Okay, so we're done with the joins. Okay, and I just want to show you how the Cartesian product works as well. Okay, what if I don't want to explicitly mention that? Okay, I want the team IDs to be compared. I don't want to explicitly do that. Then I can say, okay, you do the natural join. Okay, you yourself try to find okay what's there. Okay, oh, okay, what's the common column. You try to find it yourself and give me the result. It says okay, fine, because okay, because we only have a one single column that is common between the two tables. So it is easy for the interpreter to understand that it is the column that I am going to work on. It will do the EQ join. Okay, if we want to do any kind of non-equal, we have to use the joins and present it in the on clause, right? So we've seen the natural join. Okay, let's see the cross join. So a cross join is nothing but the cross product. So it is going to take a single record and it is going to come it won't compare. So as it's a cross join, it is going to join a single record with all the records of the other table, and it will do the same for all the records of the first table. So we're going to get okay. So let's say we have a four records in the players table, and another 4 records in the teams table. Then the output would be 16 records, right? Let's see. Okay, we have got 16 records. Okay, this is too much. I mean, why are we getting all this? I just wanted to do this to explain you how it internally works. If I select star, okay, if I select star, let's see what happens. Okay, so we got okay, so it has picked a one row, okay, a one row of the first column and appended the first row uh, of the second table. It did the same with the second row, with the third row, and with the fourth row. So it has appended all the rows of the tables to this single column. Uh, Sorry for this. Okay, for the single record, 4 of them were appended, right? So what is the use of it? So it is very, so if you were to say this, so this is a Cartesian product. Then we are going to apply a condition saying that okay, if the team ID of this table 1 is equal to this team ID of the table 2, then only you just fetch this record. So in that way we are ignoring all of this because they don't comply to your condition. So we will only fetch this and this. So okay, that this record will be fetched, will be fetched as these two are matching, and here this record will be fetched as these two are matching, and here okay, this record will be fetched, and then this record will be fetched in a join if you are applying the on condition, right? So this is how the cross join is actually the most fundamental idea. And on top of the idea, if you have some common columns, then you can use the on condition to define the condition and get the values, right? So this is how joins work. Fine. Now okay, the next one that we were to see is the correlated subqueries, right? Okay. uh, for correlated subqueries, let's see something easier. Okay, I do have an example here. Okay, let me copy that. Okay, let's see this example. Okay, here I'm okay. We use the exist clause. So exist clause works in the exact way how we want our a subquery to work. It will select, okay, let's say this is the table. If this is the table, it is going to select one record from the okay, it is going to select one record from the outer table, and it is going to compare that single record. Okay, it is going to select this record. It is going to compare that record with each and every row of the inner query. It is going to compare with all of them, right? And when it okay, when all of the processing was done on the inner table, it will return if it has found anything valid for that condition. So it is going to return true or false. Okay, it will return that true or false to the where condition, right? So we can directly use that result in the aware condition, or we can use something called as this exist clause. It is going to do the same thing. It is going to check if there are any rows returned by this inner query. Okay, if we have given some, okay, if we have given some kind of condition in the inner query, the inner query will start executing by by using the reference of the outer query. And after executing uh, all of the records, if it has found any record that is satisfying that condition, then it is going to return true. Okay, if it returns true, so I mean it won't return true if you are explicitly selecting something like we are selecting one, or if you are selecting a record itself. Then uh, the exist clause will see if anything was fetched, and if anything was fetched, then it is going to consider it as true, and it will let the where clause know that a record exists in that inner query. Right? Okay, let's try and execute this. Okay, let's try to analyze what we are trying to query from here. So we are trying to select the player name from the players table and using the alias p, where exist. Okay, so we're trying to see that one record of p, if it exists in in such a scenario. Okay, so we are selecting one. So this is way of okay, so this is a way we are going to tell the exist clause that okay, I am returning one as I have found a query that is satisfying all the condition. Or we can literally select the entire record. It will eventually map it to true. Okay, so we are trying to select something from the player stat, where we are okay. So this is the main part. So here we are saying that from the outer table's current record player id, okay, fetch that and check in our table. So this is my player stat, and in this player stat table, okay, check for that same player id. Okay, if you have found the record of this, okay, if you were able to identify the record of that player in our player stat table, then you check for this condition. You check if the runs code were equal to at the maximum of the player stats. So we are literally trying to see if a player from this player p is the highest scorer. Okay, so we are comparing the run score. So we are getting the maximum runs. So actually this is a very great example because it actually covers uh, the nested query as well as the correlated subqueries. So whatever I have selected here, this is nothing but a nested query because it is working independently. It is going to select the max of run score from the player stat. So it is going to give you a single value, and now you are going to check if the player if the player that I have selected has scored the same amount of runs. If true, then we're going to select one. So if we are selecting the number one, so the exist clause will eventually understand that okay, we have found something, so we can say I can select this player name. So we are going to select the player name as we have found a record that, so we have found a record that was satisfying the condition internally, right? So if you were to see only this part of this query, so this is nothing but a nested query. But if we were to consider the entire query, so this becomes a correlated subquery as the player is interdependent. Sorry, as there is as there is an interdependence of the outer table in the inner query. Okay, let's execute this. So we got the output as virat query. I don't know if that is true. As per the table, it might be true. So fine. So we are done with the 4 levels of queries. Now, okay, now let's look at the inline query. Right. So I don't think we need to learn much about the inline queries because inline queries are usually used when you're supposed to okay, when you're supposed to create a resource dynamically on the go. So let me do something. Okay, let's say I'm trying to select. Okay, I'm trying to select the player name. Okay, I'm going to select the player name as well as a resource. I would also like to select the max of runs. Okay, so what do you think will happen here? Here I have literally placed a select query as a resource in my front table. Okay, let's see what actually this thing does. Okay, I have selected this entire query. Let's try and run this. So we have an answer called 80. So 80 will be appended to each player, but why are we appending? Because this is not what I wanted. Let's just select star. Okay, let me select star from player stats and see. Okay, I have selected them. Okay, we have a lot of it, right? I don't want all this. I have a players as one of my resource, and I need another resource. So what is the resource I wanted? I wanted to see the runs code. So I'm going to call out. I'm going to call out the runs code. Okay, so this will return me all the runs code and probably the player ID, which will make good sense. Okay, so now I'm fetching two columns, one from the player stat table, right? And I execute that. Okay, I got this resource. Okay, I got this as my output. So now I want to give this output as a resource in this select query. So what can I do? I am just placing this inside the bracket so that it would be readable. Okay, so now I'm placing it. So what is my expected behavior? So my expected behavior is that so all the records of this table, or you can say this resource, and then whatever there is, so and what is there in this players p, so these two values are going to be joined. Okay, on what condition? There is no condition, so we are going to get a Cartesian product, right? So this is no, okay, this isn't a great example, I would say, but okay, let's run this and see what the output we get. Okay, we didn't get, so we did get an output, but okay, oh sorry, we're not selecting anything. Okay, and there's another, okay, and there is another thing, we can call it, okay, we can make this as an alias. So let me say this is called as stats. Okay, I'm calling it as stats, and in this select I'm going to call the p dot player name, and I'm going to call the stats, I'm going to call the stats dot runs code. Okay, right. Okay, now let me run this. Yes, so I got this. So why did this append? Okay, okay, yeah. So this is somewhat fine for MS Dhoni and Rohit Sharma and Virat Kohli. We got 50, 50, 50. So we have cross joined it, but okay, this is okay, and even Rishabh Pant, right? So for okay, this single record was appended to all of them, but this is not what I wanted. Now I have a player ID. in players as well as in stats. So why can't I use a join condition? Yes, I can absolutely do that. Okay, I'm going to say on condition. I'm going to say p dot player id. If the player id is equals to my stats dot player id, only then you display the records, right? Now let's run this. Okay, there was okay it's saying that p dot player was an issue. Okay, so, oh, sorry. So if we were to use the on clause, we have to say join. Without using the join clause, we cannot use on. So since we said join, I think it should be fine now. Yeah, it's fine and it's working. And did we get the expected? Yes. So these are the runs scored by Virat Kohli, and these are the ones for Rohit Sharma. This is for MS Dhoni. So we got a good mapping because we had a common column, right? So we have a common column. So on which we were able to apply this condition and filter out all the other unnecessary rows, right? So this is about the inline query. So I think you did get a good understanding of it, right? So now let's move on to the example that I was excited about more. Okay, let's learn about the CTs, the common table expressions. So I don't know why the common table expression was, you know, it is more or less how we write inline queries. If you feel that inline queries are not readable enough, so you can make them as a separate resource by making them a CTE, right? So I kind of did the same thing, or actually let's try to mimic this one as well. Okay, let me put all of this into a CTA, right? So let me write. So let's see how to write a CTA. We have to start with the with clause. We have to say with, and now give the name for it. You can name it as okay. Let me say stats dot. Okay, you can say stats. That's fine. Okay, you don't have to use. Okay, yeah. I'm gonna say stats. And okay, stats. And if you want, you can write what is the expected. Okay, what are the expected columns from this? I'm gonna say player name. Okay, let me just wait. Okay, as okay, you can use the as, and inside the brackets you have to provide the command. Okay, so we are expected to select these two. So I'm going to give them this definition. Okay, I've pasted it. Okay, now we have made this as a CTA. Now this can be used anywhere. Okay, now we can use this anywhere. So how to use it? You just have to call. Okay, you just have to call it uh, in a very similar way. I don't think we need to change anything. Let me run this and see if we get any issues. Okay, let me run this. So we are getting the same output. So CTs, okay, this is so they actually improve the readability of our script. Not so useful as an application programmer because we are not concerned about writing the common table expressions from our application APIs. But anyway, it is a very good feature of the DBMS to provide such kind of features to interact with it. Okay, and we did also talk about okay okay we did talk about the recursivity. Okay, okay. If it, I think it would be better if we slightly speak about that as well. Let me select start from people and let me simulate. Okay, let me simulate the. What is this? Okay, let's say wicket keeper. Save to the DB. Fine. Okay, now so in this okay in our in the previous video I did explain an example using the recursive CTs. So the recursive CTs work okay. I think I have explained how they work, but if we were to create an example for that and explain, I'm going to create a small example here. Okay, let me create a table called employee. Okay, let me call it as employee A, EMPA. So create table. Okay, I'm going to create a very small table just for the purpose of explaining. So it is going to have an ID of type integer, and it is going to have name of type varchar. Cannot varchar. I'm going to use only a single name. I'm going to say char of one. So I'm only going to use a single character as a name. So just forgive me. And then I'm going to use something called as an mgr ID. So this defines the ID of the manager to which this guy is referring. Okay, so let me create this table. The table's created successfully. Fine. Okay, let me insert a few records. Okay, insert into EMPA. Okay, let me insert. Okay, no, I have to write values, right, into a values. Okay, I'm going to insert one, and I'm going to give the name A. Okay, and okay, there is another thing. You cannot use the double quotes in SQL. It so you're always supposed to use the single quotes, right? So it will give you an error if you try to use the double quotes. Okay, and then the manager ID. So since I'm assuming that A is himself the manager, I'm gonna give him the value null, because he is not reporting to anyone, right? Okay, I'm gonna create another one of ID2, and I'm gonna name him B, and he will be reporting to 1. Okay, manager ID. And then I have another guy 3, and his name is C, and he's reporting to 1 as well. And then I have another guy 4, his name is T. Sorry, his name is T, and he will be reporting to 2. Okay, so I think I have created a 3 levels of hierarchy. So this is so A is at the level 0, and B, so since he is reporting to, okay, he is reporting to a manager, so we can say he is of the level 2. And then a C is also reporting to the manager, so he is of level uh, 2 as well. And then we have D, so D is reporting to 2, and 2 himself is reporting to 1. So uh, D is actually in the level 3, right? So how am I supposed to write, an SQL query to actually upprint such a thing, right? So for this, so for the same purpose, we use the CTs. Okay, so let me write one CT for this. Okay, let me first select all these values. Okay, let me say select star from EMPA. Okay, since it's case sensitive, you're not supposed to write it anyway. Okay, let me run this, and okay, you can see, well, nothing's inserted. So didn't I execute this command? Interesting. Okay, so there is a missing semi. Okay, there is a missing comma. Okay, let me execute this. Okay, so we didn't insert it in the first place. Okay, now let me select. Okay, fine, so we have it here, right? So what am I expecting? I'm expecting to have another column called levels. So it is going to show where this employee stands out. So A is at level 0, B and C are at level 1, and D is at level 2. So and also don't think like the manager ID is same. Okay, it doesn't work the way. So we are going to create the levels. Okay, so let me create a CTE first. Okay, it should be recursive, so we can use a keyword called recursive, right? So now it is a recursive CTE. Okay, now let's name it. So let's name it as an employee hierarchy CTE. Okay, some name, right? Okay, now we're gonna say as, and we will define our block of code here. Okay, so I think I have discussed what is the syntax. How do we write a recursive query? So recursive query will have a base case here, and then we use the union or union all whatever, and then we will have a general case. Okay, so what is our general case and what is the base case? So in this case, so we can say, so which level is unknown to us in advance. So we can definitely know that whoever is having the manager ID as null. So we can say they are of the level one, right? So it is a case that we know for sure. So we can say select. So we can just select. Okay, okay, we are supposed to select everything, and we need to add another column. So let us name that column as level. So we're going to create a column, and and what should what should it hold? It should hold one. Okay, when should I give? Okay, when should I give a one as a level? We can give one as a level. Okay, from empa, where empa where the mgr id, okay, the manager id is null. If the manager id is null, then we can say he belongs to the level 1. Okay, even if we have someone with a null value, then we can say he is also belonging to the same level, right? So we have defined that if anyone has their manager id as null, we define them at the level 1, and then we're going to write this union all clause, and then we will come back to our general clause. So what are we supposed to do generally? Okay, okay, see here I can observe that. Okay, when I'm here, I can see for this record the manager id is 1, and I'm going to see. Okay, and remember this, so this is already processed, and this will be kept in a small internal memory, which is used by the recursive city. So in that buffer we will have this. Okay, then okay, we will have, so in this a select clause, so we will get a record, right? So we will get this record, and it will be given the value 0 as a level. Okay, if we try to, okay, can we run this? Okay, we can run this. So it is one intermediate result. Okay, it is one intermediate result. So this result will be stored in a temporary buffer, and what happens afterwards? So it can be referred by the name emphircta, because this is where it will be present, right? So we can refer to this value, to this record using uh, this reference. Okay, now let's get back to, let me select start from maybe. Okay, so we have this record along with the level in our temporary buffer. Now, now what am I trying? Now I'm trying to select. Okay, now I'm trying to select not everything, because since we are going to do some sort of join, I'm going to select the ID and name and the mgr ID, and I'm going to select something as level. But what should I some okay about what is the something? Okay, let me first write the resources such that, we've we will get back to this. Okay, so now let's write the resources. Okay, from empa as a, I'm going to join it with the record that we have in our in this buffer. Okay, I'm going to do that. Okay, I'm going to join it with the emp hierarchy city. Okay, so what is it holding as of now? As of now, it is holding this record, right, in its internal buffer. So it will be fetched. So let me give a name called e, Okay, uh, right. And now if you remember, uh, both of them have this ID column as well as the mgr ID column. But how can I identify if this record B, if this record B is 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 a sub of this you know whoever. Okay, how can I identify? If I can find the manager ID of this record B within within my employee hierarchy CTE, I can say that I have found some, okay, some manager in that buffer. Then what would be my level? So my level would be one extra of the level that was already present in the buffer full. Okay, so firstly I have to um, okay, I have to bring them together. I'm going to write e dot managed ID is equals to sorry, not a dot managed ID. Okay, a dot managed ID, if it is equals to my e dot ID, so that means I have found my manager in the buffer. So I have my manager okay, I have my higher authority in the buffer. Then I can ask for his level, right? Okay, first of all I have to select okay, since we're using union all, so we're only supposed to have the same, the same sequence of columns in both of the select statements. So I have to write a dot id and a dot name as well as a dot mgr id, and I have to select my, okay, I have to select my higher authorities level. How can I select his level? I can use the reference e and I can call his level since it is already present, right? So okay, since it is already present, I can call his level and I can append one to it and I can call it as my level. So now I have my own level, so which is one more than my higher authorities level. How did I find my higher? How did I able to find my higher authorities? I used the internal CTS buffer memory to find out if my manager ID is present, and since I was able to figure it out, I bought his level and I have increased it by one and kept it as my own level, right? Now, okay, and I think we are done here, by the way. So we did union also. This is how my city looks like. Okay, let's remove all these useless things. Okay, fine. Okay, now this is my city. Okay, then how can I activate my city? Okay, to activate it, you just need to select it. Okay, let me select star from this EMP hierarchy. Okay, now let's paste it. So this should work. Hope so. Let's run this. Yeah, it works. Okay, see. Did we get a did we get the desired output? Yes. The one with a no manager is actually considered a manager, so he belongs to the level one. And then we have two records B and C who are reporting to this guy, so they are of the second level. And then we have this guy D. He is reporting to 2, and 2 himself is reporting to 1, and 1 is reporting to no one. So to reach the hierarchy I have to cross 3 levels, so I have assigned the level 3. So this is how we can use the recursive cities to kind of recursively call, and I did explain how it works internally in the previous video, so you can go back there and check. And that's all for this video. We'll meet you in another one.